Okay, so we're going to continue our travels in exam 2, and we're going to take a look at question 26. And we're going to see that we have a mean mu of 200 and a sigma of 20. And I think you're just going to die when you see this one. So you have the probability that x is greater than 200. And this is going to be the probability that z is greater than 200 minus 200. Sorry about the zeros. Over 20. And that's going to be the probability that z is greater than 0. Okay, so let's draw our picture. So here's 0. And we want everything to the right of 0. But when we think about this, we think, oh yeah, the normal curve is symmetric. So what do we know about everything to the right of 0? It has to be 0.5. So that's all there is to it. Nothing very dramatic. Okay, onward and ever forward. So 27, this is another one of those sneaky ones where they give you the variance. So the first thing you have to do is drop that down to standard deviation. So here you have your variance of 25. So you have to bring that down to a standard deviation of 5. And in this one, you're looking for the lower 15%. So let's draw our picture, our standard normal curve. So you always start with that and then plug it into that other expression. Okay, so there's your 15%. And I want to find that value where the shading stops. Now when I look that up, the closest hit I got was 1492. You'll see that they must have used an approximation or used a computer or something. But the value that's attached to the 1492 is minus 1.04. Okay, so I'm going to put in 15 plus a negative 1.04 times 5. And that's going to be 15 minus 5.2 or 9.8. And if you look at the answer online, I believe it was 9.825, something like that. But this is very close to what they have. There wasn't one but that was closer than this, so just go with this one. Okay, next problem. We're just tearing them up today. Okay, where's my next page? Here's my next page. Okay, so on this one, problem 28, we're going to use the central limit theorem. So we have a mean mu of 90. We have a sigma of 24. And a sample size n of 36. And we want to find the probability that the mean is greater than 94. Okay, so we have the probability that z is greater than 94 minus 90 over 24, there's your sigma, over the square root of n, which is 36. So I'm going to have the probability that z is greater than, I'll have 4 in the roof, I'll also have 4 in the basement, and that's the probability that z is greater than 1. So you've got the greater than, so you're going to have 1 minus, and you'll look up 1 in your table, and you're going to have 0.8413, and when you do your subtraction, you'll end up with 0.1587, and they ask for percentages in this one, so it ends up being 15.87%. Nothing too dramatic there. Okay. And then the final one in this movie is sneaky but effective. So they want the probability between z and minus z is equal to 0.9030. Now this is kind of a dopey formula, but it works. I don't want to know what that is. There's just some strange noise in the apartment. Okay, so you're going to take 0.9030, divide it by 2, and then add 0.5. So you're going to have 0.4515 and add 0.5. You're going to get 0.9515. That's a probability. And the z that's attached to it is 1.66. That's all you have to do. Okay? Isn't that exciting? All right. Thanks.